Hello. I promised to share uh, how I did the analysis of house prices in Tashkent. This is not a deep analysis. I just wanted to have a look at the data and to have some findings. So let's begin. Uh, in my data set, I have only four columns. Basically, how I started, there was a website of house prices. It's called like not like this, but like this. Share the link later as well. So you just go there and then we'll see the houses. What I did was I just wrote some Python bot, which will scrape the data from here. It will get the price of the house. It will get how many rooms it has. It will get the area and it will get in which floor this apartment is located. So this data, I just collected this data and saved it in Excel file. It's right over here. It has price, rooms, area, floor, columns. There are no null values so far. If I just see the summary statistics, I can see there are 288 apartments I have so far. But actually, in this website, there are more apartments. I don't know why I didn't get all of them. I will try later. And the average price. By the way, uh, here, as you can see, the price is shown as 2,672. What does it mean? In reality, I just divided the real price to 1 million to get rid of these six zeros. So whenever you see 2,673, this actually means 2,600,000,000 Uzbek sums. Let's move on. So the average price 664 means the average price for the house is 664 million sums. By the way, here is the code where I divided the price into millions. Let's see the distribution. Here are the prices on the x-axis and the number of apartments with such price on the y-axis. So it's, as you can see, it's just right skewed. Most of the houses are between 0 and 1000. What does it mean? Again, let's remember that this 1000 actually means 1 billion sums. So approximately in this area, you will see most of the house prices. I wanted to see the outliers. What are the extreme values in my data set? And I just wrote some code, first quartile, third quartile, and the outlier houses with extremely high prices can be found here. So whenever you go to the website, you will see just this first one is just the extreme one with a price of 2 billion sums and 1 billion sums, etc. So there are approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 houses with the highest prices. What I did was I just tried to see in the scatter plot how area and price correlated. It's not a secret, it's just super obvious that the higher the area is, the higher the price. But as you can see, most of the houses are just located in this area where you have an area up to 120 meters square. By the way, area is in meter square, and the price is between like 0 and 2000. A majority of points are crammed into the bottom left of the plot, making it difficult to assess whether let's say if I just draw a line, regression line, it's a good fit or not. What I did was I just wanted to see how apartments with different number of rooms are distributed. Here is the plot showing obviously like the apartments with the higher number of rooms. Apartment with 4 rooms have like higher average price than the apartments that has like the lower number of rooms, etc. And I just tried to use linear regression to predict the price, and I took price as a y variable, area as a x variable, and here this number shows like 0.50, which is not kind of good number. It's showing that my model is not quite not performing very well. So this is just a simple linear regression with just one variable. Later I will try to include such variable as number of floors and number of rooms and in which district this apartment is located, etc. Here I just tried to show the apartments with different number of rooms and their prices. Here another maybe interesting insight: average price of apartment based on the number of rooms it has. Apartments with one room has average price of 333. One more reminder that 333 means 300 million Uzbek soms. So if you are looking for one room apartment, then this is the price that you should target. If you are looking for two room apartment, the average price is 532. Three-room apartment 719. Four-room apartment 960. What else? I just tried to predict the apartment price with the area of 50, 60, 70, 80, 90, 100, 110, and 120. This is just the standard areas that people search for, as I understand, and these are the prices that I got depending on the area. So it's just a prediction I have, and this is the area of the house. As you remember, my prediction model is not performing very well, so this number will vary in reality. So this is my prediction model, and these are the actual numbers. Definitely, it's not kind of super linear distribution, so I have to work on some other prediction model as well. Distribution is like showing better fit when I transform the x and y variables. As you can see, if I use just the numbers itself, area, meter square, price, Uzbek sums, it's just showing this fit. But if I use like natural logarithm of y variable, x variable, my line is fitting better, and even r squared is higher. It's not 0.50, it's 0.56. A little bit improvement in the model. And I can see this REC, r squared of 0.12. This is in the same unit as in y. So basically, this means that difference between predicted house prices and existing, by existing I mean the house prices in my data set, actual prices, is typically about 0.12, and 0.12 should be multiplied by million because I divided by million earlier, and 120,000 Uzbek sums is the difference between my predicted prices and actual prices. Basically, that's it. I definitely will work on this data set and all the other variables I can use. And so far, this is what I found. Thank you for your attention.